We will now look at the different kinds of biozones. We will start with the common varieties and then we will look at the uncommon ones also. Let us start with the taxon range zone or tail zone or local range zone or the topo zone. Number 1. Note the word taxon. So, it indicates that we will use a taxon for its definition. Taxon is singular, so it means that we are going to use a single organism. Range zone, some range is being said. What is that range? It is the range between the first appearance FA and the last appearance in a succession. And note, I have used first appearance and last appearance. You can put a question whether FA is equivalent to first appearance datum, whether LA is equivalent to last appearance datum, whether first appearance is equivalent to first occurrence. This is another word used, another term used in biostratigraphy, or if LA is equivalent to LO. Suppose, just to give some number arbitrarily, 40 million year back the organism first appeared and it got vanished. The species appeared 40 million year back, suppose just putting some number arbitrarily, and 25 million year back it got vanished. So, 40 million year to 25 million year is the time range where the taxon range zone has been defined. Naturally, if this range is too huge, then it is not a good biozone indicator. You cannot say that I am dealing with T1 to T2, T1 is 2.1 billion year and T2 is 0.2 billion year, then the difference is too huge, and naturally smaller the time gap, better is the taxon range zone. So, we define in that way. Now, we will come in the taxon range zone another term, a variety, that is why I write 1A, this was 1 and this is 1A, which means that kind of taxon range zone is a concurrent range biozone, CRB. Now, here we will be using basically taxa, that means more than one. Imagine for taxon 1, this is the first appearance FA1, this is the last appearance LA1, and for the second taxon, this is the first appearance 2 and this is the last appearance 2. Then we can find an overlapping time when the taxa 1 and 2 were coexisting, and what is that? I can draw a line over here and I can draw a line over here. So, FA2 of taxon 2 and LA1 of taxon 1 is taken to define the concurrent range biozone. Earlier in this case, for a single taxon we defined FA and LA clearly in the diagram, but in case of concurrent range biozone we have taken FA of one taxon and LA of another taxon to define it. Now, in the way I have done with two taxa, we can have more than two to define the taxon range biozone. Say I have drawn the succession for the taxon 1, 2, 3 and 4. So, here what is the common domain? We can easily see this is the one and this will be the concurrent range biozone. As you see, in case of more than one taxa, this line is defined by the last appearance of taxon 2 and this one is defined by the first appearance of taxon 3. And it looks like set theory operation. A and B are the two sets, then A intersection B is found out. So, this intersection operation can be compared with the definition of the concurrent range biozone. And sometimes a mixed concept of concurrent range zone and opal zone is used. This is a new term and let us see what is an opal zone. So, we have got two major statements we have to remember. A group of taxa is used, that means more than one is used. Immediately we are not calling taxon, a group of taxa, that means more than one taxon is used in a way that the geographic scope of the interval is minimized. Here a biostratigrapher chooses few taxa. As I told you, we are dealing with more than one taxon, and the opal zone is most useful or most preferred, but it is not always. Now, let us look at the third variety, the interval biozone or the partial range biozone, PRB. Here an interval is referred, and here also we use more than one taxon. Consider taxon 1 with first appearance at FA1, last appearance at LA1, and for taxon 2 first appearance 2 and the last appearance 2. Now, in between there is a zone we can call as the interval zone, where neither taxon 1 nor taxon 2 is present, and this interval is known as the partial range biozone. So, in this case the lower boundary of the partial range biozone is defined by the last appearance of taxon 1, and the top boundary of the PRB is defined by the first appearance of taxon 2. So, in that way it is a bit similar with concurrent range biozone, where we are using more than one taxon, and we are finding, by the way, here the overlap time, and here we are finding a time range where there is no overlap. Interval biozone or the partial range biozone is also called the interbiohorizon, another name, or the gap zone. However, these two are most commonly used in stratigraphy. As you can see here, we are discussing the traditional 1D concept of biostratigraphy. 1D, a line is one dimensional, as if on vertical section whatever we are seeing, we are trying to define the biostratigraphy. But what about 2 dimensional and the 3 dimensional concept? There these definitions, whatever I have said and whatever I am going to say, will be difficult to follow. For example, I take a cuboid of rock, and here a drilling has been done, and here another drilling has been done. Now, once we are trying to find out the FA and LA, it becomes something for section 1 and something for section 2. For example, this can be the zone of occurrence of species A, and here we can find species A. Now, in between the drilling sites 1 and 2, see if I join by a line and in between another drill is made, we do not know where A will be present. Now, we come to the lineage biozone, also known as consecutive range biozone, also known as the phylozone, also known as the evolutionary zone, also known as the morphogenic zone. Consider a taxon T1 with time alters to taxon T2 and then it alters to taxon T3 by evolution, and here the word lineage comes. Whenever you find the word lineage, which means evolution is involved. So, we may define that T2 happened in a geologically shorter time range and it is possible to correlate with other basin. Then we can call this as the interval biozone, as the lineage biozone, and here as you note, we are starting with one organism and checking its evolution. Although these definitions are looking simple, but note that finding out the ancestor in fossil record is not always easy. You can identify T2, you can identify T1, but how do you prove that from T1 T2 has come? For example, in the fossil record not just T1 is present, there can be others also, let us say S1, V1, and here it becomes T2, S2, V2, and by the way, I have put here the letter T, but you never know whether this T1 is correlated with this T2 or with S2. There can be fossils of similar morphology, but they are of different species. These things create lot of trouble. So, none of these biozones, whatever I am defining and going to refer, are perfect. The assemblage biozone. Now, this is important. Here you can see the word assemblage, and clearly it means we are dealing with more than one taxa, and in fact at least 3 taxa are used. That means more than equal to 3 taxa can be used, but in some book you will find in defining assemblage zone they have said more than equal to 2 taxa. Okay. Now, what is being done? These taxa may or may not be related to each other, and their presence and absence are used to define this biozone. That means, say in this succession we have got A plus B, and in another place we are getting the occurrence of A plus B, then you can say that we are defining A plus B as an assemblage biozone, and we have correlated, and absence of the taxa has also been referred. For example, A plus B, and then you define C must be absent minus C. So, here I am writing A plus B minus C. If this is having a time significance for a relatively shorter range in the geological time, then you can go for correlation. Now, there are many other names of this assemblage biozone: xenozone, ecozone, ecological zone, phony zone, biophasis zone, the association zone. The word ecozone and ecological zone, you note eco and ecological in these places. Since we are dealing with more than one taxa, more than equal to 3 or more than equal to 2, certainly ecological situations play importance, and that is why these terms have been used. What is the meaning of biophasis or phasis? By the way, phasis means an assemblage of rocks that can indicate a paleo environment in case of sedimentary rock. In case of metamorphic rock, phasis can be a rock with an assemblage of minerals that indicate certain pressure temperature condition. In case of biostratigraphy, biophasis can indicate an assemblage, again this word comes here, an assemblage of fossils which can be correlated from one basin to another. Just to give an example of assemblage zone of many groups are involved is coral algal assemblage zone. A dot here means assemblage, or that of a single group, let us say molluscous assemblage zone, or of a specific habitat, we say planktonic foraminiferal assemblage zone. Planktonic indicates a specific habitat, and therefore, as per habitat this name is given. Or it can be only fossil fauna, or only fossil flora, or only algae, this way is also possible. An assemblage that lived together and interacted is considered. Do not bring the reworked fossils in none of the definitions of biozones, the reworked fossils, transported fossils, which can be identified by noting that those are broken pieces or much dissolution has happened, identification is difficult, then we can avoid those specimens. Assemblage zones of benthic organisms are most useful in correlation. When we are dealing with the benthic organisms, earlier we said their use is limited, but their assemblage becomes very important. And those of the planktonic organisms also have a wide use in correlation. The assemblage zone can be named after the taxa that define. For example, we have got A, B and C taxa, then we can write A dash, B dash, C and then assemblage zone. We have seen such a nomenclature here, coral algal assemblage zone. Now, let us look at the acme biozone or the peak zone or the epibole. It is an interval defined by high statistical proportion of a taxon. Let us look at a succession and say within this range we have got 3 examples of taxon A. Now, here within this we found only one example of taxon A. Within this we found 27 examples of taxon A, and here again we found 7 examples of taxon A and then again 2 examples of taxon A. This is the zone where they are maximum in number, their number is peaked, acme peak has been achieved. So, this may be called as an acme biozone, not always, but we have to check whether this zone can be correlated, whether this time range is short. But note that sometimes it may be unreliable due to the local environmental factors. What does it mean? The environmental factor may not be suitable for an organism to proliferate in number, reproduce and proliferate. In that case, it will not be high in number. In that case, the acme biozone cannot be correlated from one basin to another. To correlate the acme biozone, we should look at the 2 basins where the conditions of deposition, temperature, pressure, salinity of water and other things that can be important are the same, and then the number of fossils are very rich, then we can understand that those two might be synchronous, so that the correlation can be made. Come back to the definition. I have given the absolute number 3, 1, 27, 7 and 2. What about the statistical proportion of a taxon? This means we might be using, instead of these numbers, a proportion with respect to the other taxon. Suppose there are, in this, there are 79 other taxon found. Here we found 12 other taxon, and here within this range where we are saying there are 27 taxon A, we have found only 28 other taxon. Now we are going to see dispersal biohorizon. A species, consider that it evolves in one place and then spreads geographically. At several places, first appearance is marked and no prior information is present. If the geographic spread was fast, and the first appearance will be synchronous, and then that fossil can be used in defining a dispersal biohorizon. Say this is the place where a new species has come from S to capital S. Now this got widely spread in different places, and here we are finding S. If they were spread very fast, then we can say that these 3 capital S or 4 places of capital S can be correlated. So this correlation might be possible. There was no spread geographically, then we cannot define the dispersal biohorizon in this way, or the spread took lot of geological time, then it is not again a biohorizon. Now there are several informal nomenclature also used in defining the biohorizon. Structural geologist goes to the field whose aim is not biostratigraphy at all, and he finds that there is a bed which is rich in oyster. He is going to do some other study of structural deformation in the terrain, the deformation sequences. So what he will quickly say is that we are dealing with a bed with oysters. So this is an informal nomenclature without getting into the detail. So this is a first hand description, a field geologist description, and this informal naming has also been there. So I can say this is the first report of, let us say, a field geologist whose purpose is completely different, not paleontology. Now there are other biozones or the names that I am not covering here: extinction biozone, pseudo extinction biohorizon, pseudo speciation biohorizon, the barren zone, that means there is no fossil, completely barren, that can be correlated, species post lab zone, coiling direction zone, track zone based on the trace fossils, footprints or track, some organism moved, some burrowing organisms movement, burrowing examples, and species pre-lap zone. Now here let us talk a little about the coiling direction zone. If we look at the gastropods in the garden, there we find the specific coiling direction of the hard shell. This is a quick sketch of a gastropod, and the coiling direction can be either clockwise or anti-clockwise. Now this clockwise and anti-clockwise coiling direction has been linked by the paleontologists for the fossil specimens with the oceanic environment. A certain temperature range can create opposite coiling direction from clockwise to anti-clockwise coiling, and then again back to clockwise, clockwise to anti-clockwise coiling, and then again clockwise. This succession of some species M and the same species we are observing elsewhere, clockwise to anti-clockwise coiling direction followed by clockwise, then we can say that this anti-clockwise coiling direction can be correlated.